Hello everyone, welcome to this video. In this video, we will be solving engineering mathematics questions which were asked in GATE 2015 paper of aerospace engineering. As we can see in this slide, there were total 8 questions asked in this paper, out of which 3 questions were asked for 1 mark and 5 questions were asked for 2 marks. So let's try to solve these questions one by one. Coming towards the first question. This question is for 1 mark and is from partial differentiation. So it's from the differential equation topic. They have given the partial differential equation and asking us whether it's a linear or non-linear and what is order of it. The definition of linear differential equation is that whenever we have dependent variable, if it is not in multiplication with its derivative, or we don't have a higher power of the dependent variable, in that case we call it as a linear differential equation. But as we can see in the second part of this question, we have u square term. Hence the dependent variable is we can say multiplied 2 times and we can say it's a non-linear differential equation. And as we can see, all the derivatives of first order, the highest order of derivative is only one. Okay, in the first term we have dou u by dou t, we are taking derivative only one time. In second case also we are taking derivative only one time. Hence the highest order is 1. So we can say this partial differential equation is non-linear and first order. Hence option C is correct in this case. Coming towards next question. This question is from linear algebra. The system of equation is given in terms of x and y, and they are asking if the system has unique solution, then which of the these 4 options is the correct. So let's try to understand the basics of it. The current system of equation we can write in terms of matrix as A, B, C, D. It's a coefficient matrix. X, Y, it's a variable matrix. And E and F, it's a constant matrix. So it's in the form of AX equal to B. So it is a non-homogeneous system of equation. So whenever we get a non-homogeneous system of equation, depending on its determinant, if determinant is equal to 0 and if determinant is not equal to 0, we will get either unique solution or infinite or no solution. The only possible case for the system of equations to be unique is it should have determinant as non-zero. Okay, so you should have we'll get a unique solution only if determinant is non-zero. If determinant is 0, in that case either we will get infinite or no solution. Okay, depending on the values, depending on the subcases. But we are focused on unique solution, so let's focus on the right hand side part only. Here determinant should be not equal to 0. So if we take a determinant of matrix A, so this is the matrix A, determinant of this matrix is AD minus BC should not be equal to 0. And we can clearly say here that option A is correct in this case. It's a AD minus BC is not equal to 0. Okay. Coming towards next question. This question is from the calculus topic where it's related to the maxima and minima. Here they're asking the function y is equal to x cube minus x has how many inflation points. Okay, so let's try to write down this function y is equal to x cube minus x. The necessary condition of inflation point is if d2y by dx square at that particular point, okay, let's say at that point has to be 0, okay, and d cube y by dx cube at that point should not be equal to 0. So this is the necessary condition in order to have a point of inflation. So coming towards this question, let's take a first derivative dy by dx. 3x square minus 1. Second derivative is d2y by dx square, which is 6x. And third derivative is d3y by dx cube, which is 6. So we can clearly see this. The third derivative is constant, which is 6. So irrespective of any point x, we will always get a positive, we'll get a number 6, positive 6, which is non-zero. Hence, we can say it is satisfying the second criteria, that is third derivative at the point is non-zero, because here we don't have any independent variable x. Okay, it's just a constant. So irrespective of any value of x, we will end up with the value 6. So third derivative is non-zero. What about the first criteria? Second derivative at that point should be equal to 0. That is possible only when x is equal to 0. Okay, at x is equal to 0, we can clearly say the double differentiation of the given function y will be 0. Hence, we can say there is only one possible point of inflection. So point of inflection in this case is 0, and hence option B is correct. So it is one inflection point. Coming towards next question. This question is again from the differential equation. In the solution of differential equation d2y by dx square minus 2dy by dx plus y equal to 0 if the values of the integration constants are identical. So what are the integration constants? C1, C2 are the integration constants, are identical, let's say. And one of the initial condition is y of 0 equal to 1. Then y dash of 0 equal to what? This is the question. And they have given constants are identical, integration constants are identical. So it is C1 equal to C2, for example. So let's try to solve this differential equation. We can write down it in a simplified version. D square minus 2d plus 1 times y equal to 0. It is a homogeneous differential equation, so only complementary function will be the solution of this differential equation. So d square minus 2d plus 1 equal to 0. We can treat this f of d as a algebraic equation, and we can solve it to get the value of d. So it is d minus 1 whole square. Hence we can say d is equal to 1 comma 1. So we can clearly say here roots are real and repeated. If we have real and repeated roots, the complementary function is given by c1 e to the power x plus c2 e to the power x into x. So I'll write here y, which is cf c1 e to the power x plus c2 times x into e to the power x. Okay, so here it should be m1x and m2x, but value of m1 and m2 is same, which is 1. That's why I'm directly writing it like this. They have given initial condition y of 0 equal to 1. So when you put the value of x equal to 0, we'll get 1 as value of y. So c1 into 1 plus 0. Hence we can say c1 equal to 1. And they have already told that integration constant, the values of integration constants are identical. It means c2 is also equal to 1, considering the given statement. Now we know the c1 and c2. Let's write down the final equation. So this equation can be written as y equal to We can neglect C1 part now. E to the power x plus x e to the power x. And now we want to calculate differentiation of it because they're asking y dash of 0. So in order to get y dash of 0, we should know first y dash of x, and that is equal to e to the power x plus x e to the power x plus e to the power x. Okay, so here I'm using multiplication rule of derivative and this is what we'll get, u into v differentiation. So y dash of 0, when you put x is equal to 0, you'll get 1 plus 0 plus 1, hence you'll get 2. So option 2 is correct in this case. Okay, sorry, option is not here, we have to type the answer, so you should type here as 2. Coming towards next slide, next question. This question is again from the differential equation topic. So what they are asking in this question is the general solution of differential equation asymptotically approaches to what value? Okay, so we have to put that value in this case. So let's write down the differential equation. Dy by dx equal to 1 minus 2y. Looking into this question, we can clearly say that this can be solved by variable separable method. So dy divided by 1 minus 2y is equal to dx. And if we take an integration on both the sides, we will get log of 1 minus 2y divided by minus 2 equal to x. Integration of dx is x. So from this, we can say that log of 1 minus 2y is equal to minus 2x. Okay, I'm not considering constant here, just for simplicity, because they have not given any value of the initial condition or boundary condition. So in this case, log of 1 minus 2y is equal to minus 2x. So we can say 1 minus 2y should be equal to e to the power minus 2x. So 1 minus e to the power minus 2x is equal to 2y, and y can be written as 1 minus e to the power minus 2x divided by 2. Okay, so if we consider some constant here, what will happen? The c will come here. Let's say c will come here. It will come here again. Okay, so it's gonna become something like this. Okay, but ultimately, when x becomes infinite, this plus c will become negligible to it. Okay, so we can ignore. And we can clearly say what will happen. Asymptotically approaches means whenever the value of x is increasing or extends to infinity, what will happen? E to the power minus infinity is 0. So 1 upon e to the power infinity is 1 upon infinity, and 1 upon infinity will approaches to 0. So this entire term will approach 0. E to the power minus 2x plus c. Hence we can say that the y will, as x approaches infinity, y will approaches 1 by 2. Okay, hence option you should type here 0.5 or 1 by 2. Okay. Yep, its answer is 0.5 in this case. Coming towards next question. Okay, so this question is from the calculus topic. For a parabola defined by y is equal to ax square plus bx plus c, given that a is not equal to 0, the coordinates x comma y of the extremum are. The extremum means the point which belongs to, we can say, either maximum or the minimum value of the function. Means at that point, either we'll get the minimum or maximum point or the maximum value of the function. So whenever we calculate minima or maxima, we differentiate the given function and equate it to 0. And the same thing we'll do here. So dy by dx will be equal to 2ax plus b. After equating to 0, we'll get x is equal to minus b by 2a. Okay. So we can clearly see there are three options with a minus b by 2a. So once you put this value of x into y, we will get the value of y. So how we'll calculate y? Y is equal to a into minus b by 2a whole square plus b into minus b by 2a plus c. And if you further proceed, it is b square a divided by 4a square minus b square divided by 2a plus c. Here a will get cancelled. We'll end up with a b square divided by 4a minus b square divided by 2a plus c. Okay, so if you solve this, we'll end up with minus b square divided by 4a. Okay, minus b square divided by 4a plus c is there. Now what we'll get? Minus b square plus 4ac divided by 4a. So the point which we are talking about is x comma y will look like as minus b by 2a comma minus b square plus 4ac divided by 4a. Okay, so looking into the options, we can clearly say option C is correct in this case. Coming towards next question, this question is from the linear algebra, eigenvalues and eigenvectors. If all the eigenvalues of matrix are real and equal, then which of the following option is correct? That is what we have to find. So when is it possible if to have real and equal eigenvalues? Let's say if we take a simple example, let's take like this 2002. I will calculate the eigenvalues. A minus lambda equal to 0. So it's a 2 minus lambda 0, 0, 2 minus lambda, and determinant of it equal to 0. We can say 2 minus lambda into 2 minus lambda equal to 0. Hence lambda equal to 2 comma 2. So this is real and equal eigenvalues. Okay. But now if I take another example, maybe like this 2302. In this case also, I will end up with the same eigenvalues. 2 minus lambda, here it's 3, 0, 2 minus lambda. If we take a determinant, we will again get the same, which is 2 minus lambda, 2 minus lambda, minus 3 into 0 is 0. So that will not take any part. So ultimately we'll end up with same eigenvalues. But if you try to calculate the eigenvector in the first case and the second case, they are not identical. Okay. In the first case, we'll get two different eigenvectors, 1, 0 and 0, 1. Whereas in second case, we'll get only one eigenvector, which is 1, 0. So looking into this, what we can say that if we have so out of this option, we can clearly neglect this determinant is necessarily 0. That's not true. We can say determinant is not necessarily true. Okay, here, what is the determinant of this matrix? It's 4, correct? So it's not necessarily true. So how about the eigenvectors? Eigenvectors are linearly independent. Okay, so in this case, in the first case, they are linearly independent, but in second case we are getting a identical eigenvector. Okay, same eigenvector in both the cases, so they are linearly, we can say, dependent. And so it is, we can say that out of these 4 options, option B is correct. that eigenvectors are not necessarily linearly dependent. In first case, they are not, we can clearly say they are linearly independent, but in second case, it's not the case. Okay, we can say that they are linearly dependent. They can be linearly dependent. So option B is correct, that whenever we get real and equal eigenvalues, depending on matrix, we will have either linearly dependent or linearly independent eigenvectors. Hence option B is correct. Coming towards the next question, this question is from the numerical methods topic with the Simpson's rule. Okay, so they're asking us to find the value of the integration by using Simpson's 1/3 rule. Okay, with using one step. Okay, so integration is 1 to 2. So 1 to 2 is there. We have to insert one step here. So 1.5. Okay, so we'll create a table of x and the given function y, which is 4x cubed plus 3x square plus 2x plus 1. 1.5 is 3 by 2, we can write. Okay, and x is 2. So if you put these values of x into this function y, we'll end up with 10, 97 and 49. Okay, we just have to put the value of x equal to 1, 1.5 and 2. So this value is y0, this is y1 and this is y2, and y2 is equal to yn in this case. Okay, so whenever we are solving a question on Simpson's 1/3 rule, the formula is I is equal to h by 3 y0 plus yn plus 4 times y1 plus y3 plus y5 plus so on, plus 2 times y2 plus y4 plus y6 plus so on. Okay, so in this case, h is equal to 0.5 divided by 3 is 0.5 by 3, so 1.1 by 6 we can say. Y0 in this case is 10 plus yn is 49. Okay, sorry, it's 97 by 4 here. Okay, and if we right here 4 is 4, keep 4 as it is, and y1 in this case is 97 by 4. Okay, yeah, and now this 4 will get cancelled and we'll end up with 1 by 6. 10 plus 49 plus 97. Okay, once we solve it, we will end up with 26 as answer. Okay, hence option B is correct in this case. Okay, the sum of all this is 156, so it's 156 by 6 you can write, and which is 26. Okay, so option B is correct. Yeah, that's all we have from this 2015 paper. Thank you all for watching this video.